Hello all, welcome to Code Hub. Today let us solve the lead codes daily challenge and the problem is minimum genetic mutation. A gene string can be represented by an 8 character long string with choices from A, C, G and T. Suppose we need to investigate a mutation from a gene string start to a gene string end where one mutation is defined as one single character. That is, if this is the string for us given and we have to convert this into this is our end string, so we can change this t to a so that there is one mutation possible and such that we can reach this end string. There is also a gene bank that records all the valid gene mutations. A gene must be in bank to make a valid gene string. That is, if I want to come to end string this like this, and you can consider there is a bank where the string contains this and a string contains this. So what I can do is first I can convert this string to a which is in the bank, and I can convert this particular string to this a, and I can reach the end string which is the string that is here. So such that we have reached the end string and there are two mutations possible. That is, we have a bank array for each mutations. We have to check whether that mutation is possible by checking whether it is contained in bank or not. So given the two gene strings start and end and the gene bank, return the minimum number of mutations needed to mutate from start to end. If there is no such mutation, return -1. So note that the starting point is assumed to be valid, so it might not be included in the bank. So you can say that this first mutation is not present in the bank. But one thing we can observe that is the starting mutation, the base case can be starting mutation should be equal to ending mutation. Then we can just return 0. We are not doing any mutations, and the length of this both mutation is equal to exactly 8, so it is not that much large too. It is going to contain only a c g and t. So we can try to apply for all possible characters and try to change each character and see. That is not a big deal. So this may be a case, and if my end is not contained in bank, not contained in bank array, then also we cannot form the mutation at all. We cannot form the mutation, so we can just return -1 here in that case. Else we can try to change the mutation. We can try to explore all possible cases. Explore all possible cases in the sense, what do I mean is, we can try for each and every level we are actually changing only one character at a time, so that here we can see is, we can try to think of some graph like structure. That is, I want to see what is the minimum time to reach from the start to that end, if that is connected with some nodes in between. So considering it as a graph structure, what we can do is, we can try to do a BFS traversal. Why BFS traversal is, we can go breadth-wise, we can go in breadth manner on each level one at a time. So for each level we can increment our mutations. So finally we can return the minimum mutations if we find a string that is the end string that is in the queue. So what we can do is, we can define a string, we can define a queue, and we can put the start into our queue. And what we can do is, at that particular level we can try to change every character and see whether that mutation is possible. How we can check that mutation is possible? We can check through whether that is present in the bank or not. If it is present, we want to make that we want to make sure that it is not visited again. So we can try to have a set in a we can try to convert that bank into a set, and we can check whether it is present or not in order of one time. And also once I have found that mutation possible, I will try to erase that mutation from the set, so that I will not repeat the process again if it is found again. So we'll try to make all the possible mutations, and we will try to put in a next level. And for each and every level, my mutations will be going to increment. And finally, we are going to return the mutations if I can find the end string, else I will return -1 if my queue is empty. So this is the approach that we are going to do. So for that, we can have a queue first, and it should have a string queue. And what I can do is I can have mutations equal to 0, and finally return my return mutations. Sorry, at the end of the day, if I couldn't find anything, I will return -1. While my queue is empty, I will get the size. I will first process the that level. So for each level I want to process, so I want to push the start string into my queue. Before everything, I have to see two base conditions. If my start is equal to n, then I do not do any mutations, return 0. Then I want to convert that bank array into a set, so I will convert it into an unordered set of string comma string. I will say it as bank set. So I will insert for auto yes in my bank. I will just insert this bank set dot insert of yes. So I have inserted this. Then what I shall do is, now I can go and apply my algorithm using breadth first search. So what I should do is, while my size is present, I should go inside that, and I will try to explore all the possible cases. So first I will get the string auto is equal to q dot friend, and we can just pop it out, q dot pop. So once it is popped out, what I have to do is I want to find all possible cases. Change uh, change all possible mutations, and if it is in bank, put in queue. So what we can do is, we can have an array. We can have a simple array which is which we can say it as character mutations, or let me say it as character. What are the characters? Choices. It is named as choices, right? So choices of 4. I have only 4 choices, either A, C, G, or a T. So these are the choices that I can make. So now what I will be doing is, for this current string, I will try to change all the one character at a time, and I will try to see whether that string is present in that bank. So what I will do is, for auto, or instead of doing like that, we can say int I equal to 0, I less than cut dot size. Instead we can say it as 8. It is always 8, so I plus plus. So for each and every character, first I will get the current character in my temp. So character equal to cur of I. Now I have the current character, so now I can change the current character to my cur of I. I have to run a for loop for int k equal to 0 to k less than 4, I will try to modify it to every cases. If curve of I is nothing but the k, choices of k, but only if it is not equal, curve of I is not equal to choices of k, I will try to modify this value. Then what I will be doing is I'll be checking this current string is present in my map or not. If my bank set dot find of this current string is not equal to bank set dot in, that is if this set contains, if the bank contains this current string, then obviously I can erase this string from my bank. And once I have erased this string, I have to insert this particular string into my queue. Push to dot push off. So once I have pushed this string, what I can do is then I will go and change the next choice and see. And after finishing all the choices, once I come back, I want to restore that particular character. So color of I becomes my current character. So here I should check character. Cut character is not equal to choices of k. If the cut character is not equal to choice of k, I can replace this current character with the choices of k. And if it is in bank, then I will erase that string from bank and I will push it into my queue. As such that I am making each and every time one mutations and seeing, and we are exploring all the possible ways. Once we are completing this while loop, what I have to do is what I have to say is I have to say level plus plus. Why is it so? Because I have done one mutation. So for my next possible strings, so that particular mutation possible is that my level plus level count, which is the mutations count. So mutations plus plus. So each and every time I am checking if my current string is equal to the end string, then I can just return mutations. So like this we can do, and hope this is much better. Now let us try to run our code and see whether it is getting accepted or not. Okay, it gets accepted. Superb, it gets accepted for all the example cases. Now let us try to submit our code. Great, it gets accepted as you can see. And let us do a complexity analysis so that it will be clear for this problem. So actually we are doing a BFS here, right? So what will be the time complexity? The time complexity is quite tricky here because there is we can see the constraint is only the string is of length 8, so it is not that much big. So the time complexity is, or we are actually visiting the strings that are in the bank array. If it is, so we can say it as the time complexity to be order of b. The the time complexity to be order of b, where b will be the length of the array. But technically speaking, here we are running a loop of 8, and here inside that we are having a nested loop of 4. So considering this 8 to be n, we can say it as n into m, where it will be constant. N is nothing but it is equal to 8, sorry, where you can say n is equal to 8 and m is equal to 4. It is a constant, it is not that much big, so we can boil down into b itself, but you can say it as b into n into m. because if we insert every strings that is in bank in that queue, obviously we will try to achieve this time complexity. And the space complexity is also the same thing discussed before. We will be saying it as order of 1, or else we can say it as order of n power m, because we may make up a space of we may make up a space of the n power m states in that is visited, that is visitor which is in the bank array. And since the string length is 8, we can say it as order of 1, and the constraints is very much smaller, so we can say it as order of 1. And these are the time and space complexity. So hope you like the solution and let me know in the comments. So let us see in tomorrow's Lead Code Daily Challenge. Until then, bye.